name is Ba. I'm the science and math tutor at Today I'm gonna do some college algebra problems on the section 3.5. So I'm gonna go ahead write the question that I'm gonna do is f of x is equals to 2 into x plus 1 square minus 3. So this section is talking about shifting, like vertical shifting, horizontal shifting, reflection, and all those methods that we can use to draw a graph. So I'm gonna go ahead and use like some of those methods like vertical shifting, horizontal shifting, and stretching to draw this graph. So I already got a graph paper here. I'm gonna go ahead and put all the coordinates in there. Okay, I'll use this point here as the origin. I'll go here 1, 2, 3, 4, 5, and go here -1, -2, -3, -4, -5. Come down here -1, -2, -3, -4, and -5. Go up. Do the same thing. 1, 2, 3, 4, 5. Okay, now here I'm gonna go ahead and label this one as the y-axis, this one as the x-axis. So the question I have is f of x is equal to 2 into x plus 1 all square minus 3. I choose this question because it involves like the vertical, it involves like the horizontal shifting, and there's like a vertical shifting too, horizontal shifting, vertical shifting, and stretching. So it involves like a lot of stuff, so that I can just do everything on one problem. So that's why I choose like this problem. Okay, if you get this kind of problem, if you look at this problem, it's like 2 into x plus 1 all square minus 3. So this type of problem, using this like vertical shifting and stuff, you're gonna go ahead and look at a problem that is kind of similar to that, like a graph that is kind of similar to this one that we can graph easily. For example, the graph of f of x is equals to x squared. We can graph that one easily. It's like a parabola that opens up, so we can graph that easily. So we're gonna go ahead and compare this thing to that graph. So we can use this graph, come up with that one. So we're gonna use vertical shifting, horizontal shifting, vertical shifting, and stretching to come up with this graph here. So I have a graph paper here. I already put my coordinates, I already labeled my stuff. So I'm gonna go ahead and just write the graph here. Y is f of x is equals to 2 into x plus 1 square minus 3. So here the first thing we're gonna start with is this thing in the bracket. That's what we're gonna start with. But before we like do anything with that, we have to go ahead and draw the graph of f of x is equals to x squared, because that's what we're comparing it to. So I'm gonna use like dotted line to draw that graph, so I will not like, so if I come up with the final one, it will not be like everything will not gonna be mixed up. Okay, the graph of x squared, f of x is equals to x squared. That one is easy to draw. It's just here. You get a point here, 1 and 1, and get 1 and 1 here, because if x is equals to 1, f of x is equals to 1. So that's why we get 1 and 1 here and 1 and 1 here. If x is equal to 0, f of x is equal to 0. That's why we get this point here. And another point we can get is 2. If f of x is equals to, if x is equals to 2, f of x is equals to 4. So we get that one here too. We get another one here. If it is minus 2, if x is minus 2, it's going to be f of minus 2 is equals to minus 2 squared, which is equals to 4. So we get another point here as 4. So we get those points. We already get those points. So we can go ahead and use those points to draw our graph. So the graph is going to become like this. So this is our graph for f of x is equal to x squared. I'm going to erase it a little bit so that it will not be that thick because it's not our final graph. We're just using it to come up with this graph here. Let me write this thing there. 2 into x plus 1 minus 3. So this one, the first thing we're going to do is this thing in the bracket here. That's what we're going to do first. This one is x plus 1. So when you get like f of x plus 1 into this thing, into x squared, this is what you get. You get x plus 1 all square. That is what this thing is equal to. F of x plus 1 of this thing, x squared. This is what it's equal to, x plus 1 all square. So we're going to go ahead and draw the graph of x plus 1 all square. That is just this part here. That's what we're doing first. No, I'm not showing this. It's x plus 1 all square. That is f of x plus 1 is equals to x plus 1 all square. So that's what we're going to do first to draw the graph of that. So we're going to use horizontal shifting to come up with the graph of that one. We're going to use horizontal shifting. Right now, we're just concentrating on this part here. That's what I brought up here. So the rule says f of x plus something into that is going to be like a horizontal shifting. If it is minus, it's going to be to the right. If it is plus, it's going to be to the left. So here we get plus, so it's going to come to the right. So if we shift this thing 1 unit, because we get 1 here. If this thing was 2, we're going to shift it like 2 horizontal. We're going to shift it by 2 units, but we get only 1. If it was 3, it's 3 units. So we get 1. It's going to be 1 unit horizontally to the left. So this is the left side, this is the right side. So we're shifting it 1 unit to the left. So we're going to come like every point, we're going to take it 1 unit to the left. So if we take this point 1 unit to the left, it's going to come here. Instead of here now, the new point is going to come here. So if we take this point 1 unit to the left, it's going to come here. So instead of here, it's going to be the new point. If we take this one to 1 unit, it's going to come here. Instead of here, it's going to just come 1 unit. Like you shifted 1 unit to the right. This one too, we shifted 1 unit to the right. So it means the new one is going to come here. So now we get our new points. This one too, where it is, if we shift it 1 unit to the right, it's going to come here. So we get our new point. So it means the next graph we're going to get is going to be. This is going to be our graph. This is the graph for x plus 1 square. That's what we just drew. X plus 1 square. But still we don't reach our final goal. Our final goal is to get the graph of 2 into x plus 1 whole square minus 3. This is our goal. So we don't get there yet, but we already get this part here. So we left with those parts. So we already get that one. It said it's x plus 1, so we go horizontally. So we go horizontally, x plus 1, we go horizontally to the right, to the left, horizontally to the left. So the next one is we're gonna now come and do this part. Now we already do this part. Now our next step is to do this part. This is 2 into x plus 1 whole square. So this side is going to be stretching. We're going to stretch the graph by multiplying it by 2. So we're going to multiply this graph by 2 and stretch it. So if we multiply it by 2, it means we like stretching it. So if this thing is equals to, if f of x is equals to x plus 1 whole square, we multiply it by 2 to stretch it. So if we multiply it by 2, it means every value of y is going up by a multiple of 2. Like we multiply it by 2. If it is 4, now it's going to be 8. If it is 1, it's going to be 2. We're multiplying them by 2. So here we get 1. So here if we stretch it, instead of 1, it's going to be, we're stretching this 1 by 2. So we're going to multiply it by 2. So if we multiply it by 2, that is 2. So that one is going to come here. So the next one, I forgot, we already, the graph we're using is this one. It's not that one. That one was the first one. That one is just like the x squared. So this one, the x plus 1 whole square, that's what we're using right now. So here, if we're stretching it, it means we like multiply them by 2. So the one, if we multiply it by 2 instead of here, the 1 is going to come up here. So the 0, if we multiply it by 2, is still 0. 0 times 0 is 0. So it means the 0 is not moving. It's just going to remain here. But the 1 is moving because 1 times 2 is 2. So if we multiply this, it's minus 1 times 2. Sorry, not minus 1. It's plus 1. Plus 1 times 2 is still going to be 2. So our next step is going to be here. So we get 1 here and 1 here, and the 0 is going to remain because 0 times 2 is 0. So the next one is going to be, our next one here is 4. And this graph, I think this thing should come here. Yeah, this thing should come here. Like when I was trying to, I made a mistake bringing this line all the way here. It should not come here, it should just come here to the 4. I already put the point there, but I put the line. So this line should come all the way here. It's kind of like confusing because like a lot of points in there. So here we get 1 point here. We get 1 point here, another point here, and another point at the 0. So the next one is we're going to shift. So the next one is we're going to stretch the 4 too. So the 4, if we stretch it, it's going to be 4 times 2 is going to be 8. So it's going to be 1, this 4 here, 5, 6, 7, 8. So that point is going to come here. So we get 1 point here, 1 point here, 1 here, and 1 here. So this other one is 4. If we stretch this 4, it's going to go to 8. We get 8 here. I'll put 8 here. So that's going to come right here. So I'll use this thing is a pen here. I'll use this thing to highlight these points. We get 1 here. There's another one here. There's another one here. Another one here. And another one here. Those are the points I just get highlighted with the pen. So we draw this graph is going to come all the way up here, and this one is going to go all the way up here. So this is the new graph we get. This is the graph for x plus 1 squared times 2. So now we get this part here. We get that one. So we go for the last part to include the minus 3 there. So that's going to be our last part. So the minus 3, that one is going to be, this one is, the one we just did, that one is stretching. We stretch the graph. So the next one is going to be vertical. It's going to be vertical shifting because we're subtracting like 3 from that. So it's going to be vertical shifting. That's going to be the next one. The next one is vertical shifting. So the vertical shifting, the graph we just last get, we try and shift it vertically by subtracting 3. So if we subtract 3, it means we're going down. If we add 3, we're going up, like vertical shifting this way. So here we're subtracting 3, so we're going to come down. We subtract 3 from each point and go down. If it was plus 3, it's going to be up. So it's minus 3, we're going to come down. So this point here, we get minus 1. So this minus 1, if we come down 3 units down, like minus 3, this side is negative for y. So we're going to come 3 units down. It's going to be minus 1, minus 2, minus 3. So this point is going to come here. That is going to be the new point. So this one too, we subtract 3 on that one too. So if we subtract 3 on that one, we're going to come 1, 2, 3. Our new point is going to be come here. So the next one, 2, we subtracting 3. 1, 2, 3. That one is going to be here. So we get a point here, and a point here. Our next one, 2, we subtracting 3. 1, 2, 3. It's going to come here. 1, 2, 3. Yeah, that's right. So the next one, 2, we subtracting 3 is going to be 1, 2, 3. That one is going to come here. So I'm going to highlight this one with the pen. So we get 1 here, 3, 1 here, another one here. So that is going to be our final graph. That's going to be this thing all the way down. Yeah, that is our final graph. The graph I used to, that one is the graph for f of x is equals to x plus 1 whole square minus, sorry, times 2, it's going to be 2 here, minus 3. So that's the final graph. So I'm just going to go ahead and highlight the individual. This is the first one we drew. I'm just going over. This is the first one. This is the first graph we get. The first graph was f of x is equals to x squared. F of x is equals to x squared. After that, we shift it horizontally by 1 unit. We get this one. The one I'm just highlighting, that is the next one we get when we take it horizontally by 1 unit. It was this one. So this one is f of x is equals to 2. Sorry, f of x is equals to x plus 1 squared. That is this one here. So after that, we stretch that one. When we stretch that one, we get this one. We came all the way up here. All the way up here. So this one is f of x is equals to 2 into x plus 1 all squared, 2. So we stretch that by 2. So we get the last one, which is this one. The last one is this one here. F of x into 2x plus 1 all squared minus 3. So to find the coordinates of this one, I already put the coordinates, so it's very easy like to level those to know where those are. This is minus 3, and this one is minus 1. So here the point is minus 1 and minus 3. It means minus 1 for x and minus 3 for y. So this one, the y coordinate here is 0. Sorry, the x coordinate is 0 and the y coordinate is minus 1. So that one is just 0 and minus 1. So we get this one here. The y coordinate is 5 and the x coordinate is 1. That's 1 and 5. This one, the x coordinate is right here. It's minus 3. So this one is minus 3 and the y coordinate is 5. So we get our final graph is like the one I highlight with dots. This is our final graph. So we did vertical shifting. If it is minus, we go down. If it is plus, we go up. If it is horizontal, if it is plus, we go to the right. If it is minus, sorry, if it is plus, we go to the left. If it is minus, we go to the right, like this way. Plus is this way, minus is this way. So the other one is stretching. Stretching, you just multiply each point like by 2, like going up. You multiply by 2 going up, not like this way. Like this one was 4, I multiplied by 2. You multiply like the y coordinate by 2, not the x, because it was 2 times x plus 1 whole square. So I multiplied the y coordinate by 2. So the y coordinate at that time was 4. Was right here 4. I multiplied by 2 to get 8. So I hope you guys. Okay, I just try to do this problem because it get like many stuff. You get vertical shifting, you get horizontal and stretching at the same time. So it covers like most of the part. And we get what we call, there's something called reflection too. If y is equals to minus x squared, y is equals to minus x squared. Reflection is like, it's going to come in, if it is facing up, y is equals to x squared, that is the parabola that face up. So if it said minus, it's just going to make it come down. It's just like going to face it down. If this y is equals to x squared, it's going to face up, but y is equals to minus x squared, it's going to face down because you're reflecting it. Like this one is facing up, this one is going to face down. So if it is negative, it just like reflect it. If it is negative x squared is facing up, if x squared is facing up, negative x squared is going to face down. You see, like this thing is facing up. If we were to put negative on this, that's called reflection. It's going to face down. Instead of it being like this, it's going to come like this. That's how the parabola is going to be. So that's like reflection. Reflection is like when you get negative on it, like negative, positive, or when you change the sign. So this like all the question I'm like doing today. So if anyone get a problem in college algebra and stuff, you can come at the Nationality Center. At the Nationality Center is at, if anybody got a problem on college algebra, you can come at the Nationality Center. It's on the third floor. At the Oli building, it's like on the third floor. If you get any problem in college algebra and stuff, you can come down there. It's like a lot of, like, a lot of tutors in there. You can come down there, maybe any other subject. So I'm like the science and math tutor, normally like tutoring college algebra and some chemistry and some other maths courses. So if you get any problem in those, you can come down there.